All right, thank you. All right. Hello, everybody. I'm Derian. That's Diptendu, as you heard. And we're going to talk about malware today in NPM. I would just like to take a quick poll if you could raise your hand if you have used NPM before, typed NPM install. Okay. Yeah, cool. Okay, and amongst those of you that have you typed NPM install and then downloaded a package and not understood every single line of code that was just pulled into your project? Yeah, okay. Yeah, that checks out. And we're going to look at why that might be a little bit risky today. Because you are using NPM as your personal fetcher. It just doesn't know what to look for. It's just grab everything while you are going to get some coffee. So I'm Derian, and that's Diptendu. I was a security researcher at SemGrep, and I ended that about a month ago now to join Dell. As you heard, I'm a software engineer. Diptendu is still there. But yeah, let's get into it. So we're going to talk about a brief history, and then why are we looking at NPM, the attack vectors, the payload tricks, the types of payloads, and of course you have to talk about AI too, and then the solutions, possible solutions. Okay, so going back a few years, you can kind of see how quickly this is growing. In 2023, this is just 3 years ago, there were a little over 5,000 packages that were taken down by NPM. Separately, there was another kind of interesting spam campaign that saw over 15,000 spam packages published across 2 days. These were kind of interesting packages. Their payload and stuff was that they were basically called like free Xbox codes or free TikTok followers. And for some of these packages, the point was that you would, I guess, download them and then get redirected to AliExpress using a referral code, and then if you happen to buy something, then the attacker would have received a bonus from AliExpress. That was that. And then NPM also statistics showed over 2.5 million live packages and a lot of monthly downloads, and we'll look into why that is shortly. And then you fast forward a year, and everything increases a lot. I mean, this is just 1 year, and we've seen over a 100 times increase in the number of malicious packages, over 500,000 out of an estimated, close to 5 million packages. And these are the ones that were, detected to be malicious packages. And there were also some notable attacks as well. Luma malware on the PyPy ecosystem, won't be talking about that much, and XZUtils as well. And then coming towards last year, what we saw at the end of last year was a really kind of big increase in these sort of big name package compromises. And there was a big chain of this, and that's kind of what helped inspire this talk here. It's all started with NX Singularity, Chalk Debug, DuckDB, Shai-Hulud, Shai-Hulud 2, and we just saw mini Shai-Hulud as well. So this is only getting worse. So why are we looking at NPM specifically though? NPM has what feels like infinite packages. Obviously not actually, but we saw the numbers earlier. There are more than a few of them. And the reason for this is that JavaScript actually does not have a really good standard library like how Python does. You can just import some standard packages and have some pretty basic functionality out of that. JavaScript doesn't have a good library for that. So then because of that, we see a large amount of what we call these one function wonder packages come out, where it's like a package is uploaded to NPM that does one thing that is convenient for a lot of people. One problem with this is that it then builds a very big dependency graph for any given NPM project. There was a study linked at the bottom there that showed that the average NPM-based project on GitHub had 10 direct dependencies. That's okay, but that resulted in 683 transitive dependencies, which are the dependencies that your dependencies depend on, if that makes sense. Just one step up the chain. That's sort of the main reason, but also it's very easy to publish for NPM. This is true for other ecosystems too, and I mean, this is kind of changing a little bit now, but it is generally pretty easy to publish NPM. No reviews, no sandbox or no questions. They don't interview you. You just say, here's some code. I want it to be called this, and they welcome it. NPM runs everywhere, so it's a very large attack surface. And also, the lifecycle scripts, like pre-install scripts, post-install scripts, these run by default as well. So that is also opening up some more attack vectors for, easing simplification of malware getting into your environment. This is an example of one of the one-function wonders that I was talking about. It's this package called isWindows. And you can see on the left-hand side that it is a relatively popular package at nearly 24 million weekly downloads. And then on the right-hand side, you can see the entire source code, all 27 lines of them. And it tells you if you're on Windows or not. Okay, yeah, so we'll get into we'll get into some attack vectors now. And this goes left to right, increasing in both ROI and difficulty of execution. They are kind of one-to-one here. So on the way left, we're starting with these randomly named malicious packages. Then we'll look at typo squatting, dependency confusion, and maintainer account takeover, which is what we've seen a lot of lately. Okay, so starting with these randomly named ones, generally these are sort of uninteresting because it's very unlikely for you to, type npm install and then type in a random word and get malware. There are some implications to this, though. If you think about it, I guess every single package that you use now that is extraordinarily popular once started like this. So who was the first person to download that, I guess? It could act kind of like a Trojan horse. That's certainly possible. But generally, it's kind of difficult to start like that. You have to build some degree of reputation first. But also, as I mentioned earlier, there was the huge, massive spam package campaign, the over 15,000 ones in 2023. That's also another sort of implication that you can have with this. Another one is one that also happened, I think, late last year, was that there's this platform. It's called t.xyz, and basically it's a platform that rewards you for contributing to open source. So what happened was someone had created an account, I guess, and then made I don't even remember how many packages, like 500,000 packages, just randomly named, nothing to it, and then just uploaded all of them to NPM. And that was designed to inflate their score and make it look like they're a great developer. But yeah, it's much less likely to cause some real harm with this, but there are still other things you can do with that. But we'll get a little more interesting. Another show of hands, please. Has anyone here ever made a typo in their lives ever? Okay. Yeah, I have too. That happens quite frequently for me still even. For example, we have this legitimate package called Lodash, and you see a lot of permutations up here. This is, what myself and ChatGPT could come up with to, just simulate some different ways to misspell this by accident. For example, the very first one, Lodash, you just miss the S, and suddenly you download malware. And, you can come up with a bunch of different ones. So, for any, given legitimate package, you could have, I guess in this case, 9, probably more, malicious packages. This is the NPM page for the Lodash, the one with missing the S. So it's still there. It's still real. It still exists. You'll see that it is a security holding package now, which is good. It means it's not malware anymore. But what's more interesting is if you look at on the right side, the red circle, the weekly downloads, is that people are still downloading it. So it's still a very real attack vector. But that does bring us to the bright side here. As you saw, it was a security holding package. What that means is they took it down, says this is no longer, there's no real code in here. If you want to use this name, just contact us. NPM and the NPM community is very good about reporting malware like this, especially for typo squatting and stuff. So if you go to any of those given permutations that I showed you, I'm sure that they are security holding packages by now. And that is probably true for just about every single typo at this point that you can make. That said, I wouldn't recommend making typos still. Copy and paste is probably a little bit safer because, I don't know. You could make some pretty crazy typos, possibly. All right, so going down again, dependency confusion. This is a little bit more targeted attack. It's a little bit easier to cause some damage here, but if you know how to do it correctly. Basically, if you work at some very large organizations or something, they can internally host some custom proprietary packages that they made within their own organizations. And it's intended that these are not exposed to the public. But if you can get some information on what these packages are, what are they called, ideally what's the version numbers and stuff like that, what you can do is you can create another package that is malicious to the public registry. And you can name it the same way, and then just list the version at an arbitrarily high number. And then if you have, for example, any workflows that just automatically install the dependency because they trust that their internally hosted package is safe, the registry is actually going to prefer, by default, the public instead of the private. So if you upload malware at a very high version number, it's going to end up downloading the the malware because the NPM thinks, oh, well, this is newer, we must use this. This does require you, though, to have some internal information or just be very good at guessing. And also the impact here is kind of limited to singular organizations rather than everyone that has ever typed npm install. Yeah, so here's an example. This is PayPal. This is likely an internally hosted PayPal on the left side anyway. Maintainer account takeover is the, this is kind of the gold standard for, making the news, I guess. So this does require another step, a very difficult step of compromising the maintainer's account in the first place. But, for example, if you go back to Lodash and you don't want to make a typo because they'll detect that immediately and throw it out for you, what if you could compromise Lodash itself, right? So if you could do that, and maybe what happened with XEU deals is that there was a contributor to it that built up a lot of trust and then eventually just released some malware and nobody really questioned it for a long time. So if you could do that, then people will automatically download the latest versions, assuming they don't make a typo, because all the trust is already there. You already know that everyone uses it. You used it for a while, and all the stars, all the downloads, it's all there. So there's no reason not to trust it. Well, there is now a reason to not trust it. But this is what kind of makes the news. Because you really would be inclined to, just like if you see that, oh, there's a new version of Lodash out, you would be pretty inclined to go download that immediately. And if you don't give it any buffer time to detect any malware, you could be in trouble if you're not really careful. For the chalk debug compromise, this was the phishing email that got the maintainers. And this does look pretty good. Even if you'll notice the sender email, the email that, the phishing, the fake email, was support@npmjs.help. But, the real one is support@npmjs.com. So you could even, that's kind of like a tricky difference there. Like you might want to just be, adamant about double checking everything because this is, obviously very well written. Yeah, and so you can see this is another example. This is the NX one, very popular package. It's the legitimate one. And you can see on the right side that it is shown statistically in history that it has had malicious versions released. Yeah, so those are the so maintainer account takeover is the gold standard if you want to release some malware. But I'll pass off to Diptendu now to talk about some payloads.
Thanks, Derian. So what we have seen, what are the payload tricks, how malware gets delivered, is using the lifecycle scripts like we noted before. There are a couple of attributes in the lifecycle script that can be used, like pre-install, post-install, prepare. So what they do is they were meant for testing. Like after you install the package, you can test, have I installed it correctly? That was the initial intended purpose, but there is nothing that limits you to do anything else. So you can do basically anything. So if you use pre-install and call another file, it will execute that file if it is within the package. And the contents of the file is in your control. So if you write a malware, it will run the malware. Not only that, but you can also fetch any content from outside. It does not have to be the malware is inside the package pre-built or pre-packaged, you can like say like, hey, get from this URL, pipe it into bash, and it will still run it, basically. So these pre-install and post-install hooks are mostly leveraged by attackers. There are other ways, like there are some attacks which did not leverage this pre-install, post-install, but what they did was they kept the malware inside like the index.js or any other random JS file, which is a part of the package, right? So what happens is nothing runs during install time, but when you write require or import, at that point of time, the file gets loaded, and at that point of time, the malware runs. So it's a bit different. Another way we have seen is that, as we said, like maintainer account compromise is one of the highest impacts one. So let's say I am the maintainer of TensorFlow, right? And my tokens get compromised. An attacker releases a new version of TensorFlow with the malware, but how they do it is they do not write the malware in a way that like there is nothing in pre-install, there is nothing in the files, all of the files are exactly same. What they do is they change a dependency or they add a dependency. The dependency is in their control. So when the new version installs, automatically it will install a dependency, and the dependency is bad, not necessarily TensorFlow is bad. So these are the possible ways that we have seen. So the types of payload, according to each attack, so going from left to right is defense evasion. We start with readable malicious code, which was in the NX attack. Then we have minified code, which was in the Shai-Hulud worm V1, version 1. Then we have obfuscated code. We had seen that in Shai-Hulud 2, as well as chalk debug. And then we have bundled binary. So this was an attack on a package called ESLint config prettier, which happened in July of last year. Right, so there is a subtle difference between minified code and obfuscated code, which is like the purpose of minified code is to save space, but the purpose of obfuscated code is to not let you do any analysis. That's like kind of one of the big differences. Right, so how did the NX attack look like? So if you see in the bottom right, you'll see it leverages the post-install hook. It says node telemetry.js. So it will run the file telemetry.js. And this is the content of telemetry.js. And if it's readable, like if you go through it, you will see that there on the right-hand side, I can see there is an upload repo called github.com repo full. I am uploading it. I am naming it Singularity repository. On the left-hand side, I can see like I am running who am I, this, that. So, I mean, you can, if you go through it, like a human reviewer can basically guess this. Yeah, it is not something which is doing anything good, basically. So what it does, the TLDR for this is, it obviously collects your environment variables, all of the other credentials, uploads it to GitHub, names it Singularity repository, triple base 64 encodes all of the data. What was interesting here is this file had some built-in commands which checked that are you running any AI agents like Claude, like Gemini? If so, it had a hard-coded prompt telling the agent that, hey, look everywhere inside the file system, give me all of the juicy details, and export that as well. So it was leveraging AI agents, this particular malware. Okay, next we come to the minified code. So here also we can see that it is leveraging the post-install hook. It is running node bundle.js. And this is like a snapshot of the actual node bundle.js file. So we can see it is a bit more difficult than the previous one because it is not readable, it is minified form, right? So this becomes a bit more difficult to analyze directly or manually, but like what it does is basically this kind of does the same. It leverages a legitimate secret scanner called Trufflehog. So it does not run manual commands. It downloads and runs Trufflehog. Trufflehog collects all of the secrets, and then it exports. But this is also a worm. So how the worm feature works is that whenever you install this malware, it searches for, do you have access to other GitHub projects? Do you have access to other packages? If so, it is going to create a new version of that as well and include this bundle.js as a part in that. So that is how it keeps propagating. So if you have more access to other packages, it will keep replicating and propagating. Okay, so next we come to the chalk debug attack. So if you see on the bottom right, there is no pre-install or post-install here. Instead, if this is the index.js, and if you see line number 7, it looks kind of like funky. This is line number 7, if you like expand it, and this is obfuscated code, and when you see it, it goes like, wow, what it is doing, I have no idea. Right, but like it involves reverse engineering, obviously, and there have been researchers who have done it. The TLDR for this is a cryptocurrency stealer. How it works is it hooks your browser, and it has hard-coded attacker addresses. So whenever you are just about to make the transaction, like I am probably sending money to Derian's address, it will just swap Derian's address with the attacker's address. And instead, the transaction will go to that attacker. And they had for every possible like cryptocurrency you can think of, Ethereum, Solana, Bitcoin, everything. Everything was hard-coded. The good news is only about $50 of cryptocurrency was stolen before the package was taken down by NPM. So that's a win. This is the obfuscated code for Shai-Hulud 2. This is an upgraded worm from Shai-Hulud 1. So on the top left is the package.json file, which says, hey, run setup_bun.js. On the top right is setup_bun.js, which says, does bun environment.js exist, this file? If so, then run it. And this is the content of the bun environment. I mean, it looks pretty same as the previous one, but if you pay, I mean, if it's visible, you will see in paragraph 2 in the beginning, there are a lot of google.something, if you can see it. Google.something, google.something. Keep that in mind, it will come in handy very soon. Okay, so the TLDR for this is, it is kind of like an upgraded version. So Shai-Hulud 1 used post-install. This uses the pre-install hook, kind of same, like one runs before the package and after the package has been installed. Shai-Hulud 1 was minified, but the attackers then upgraded themselves and made this one obfuscated, right? So this does not create a specific repo name. It creates a very randomized repo name. The description is, however, fixed, which is Shai-Hulud, the second coming. That's why it got the name Shai-Hulud 2. Now, Shai-Hulud 1, when enabling the worm feature, would look for 20 packages, up to 20 packages. Like, do you have access to 20 more packages or 20 more GitHub repos where I can infect? This one looks at 100. And the bad part is, if it cannot find any authentication tokens like GitHub or like NPM, it is going to wipe your directory. That feature was built in Shai-Hulud 2. At the time of infection, we can see that there were about like 26,000 repositories in GitHub. It exfiltrated 3 files, cloud.json, contents, environment. All of them were like triple base64 encoded, so if you just download and run it triple base64 decode, you would easily see all the secrets. Right, so we come to probably the hardest analysis-wise, which is bundled binary. This attack happened on July 18th, so this is before the Shai-Hulud ones, right? So this affected this list of packages, and so how this worked is like in the install.js, you will see there is there a node gyp.dll file? Then run that DLL file, right? So that's how it invoked it, basically. So similar to like run this JS file, this one did run this executable or run this binary. Right? So same kind of like execution, the file type is different. Here is an example where automation went wrong. So when the malicious version released, 9.1.1, we know about Diptendu, right, which suggests that, hey, there's a new version, do you want to merge it? And there was similar to Diptendu this version, this bot, who said, hey, I see a new version, I want to merge it. And somebody did merge it, which was malware, right? So the problem is that Diptendu only checks if there is a new version. It does not check that is the new version good or bad. That's the problem. So as soon as it comes out, it is going to like suggest, hey, you want to merge, and if you merge without analyzing, this is going to happen. So unfortunately, I could not see, like I could not locate the file, this node gyp.dll, to like show what is inside that. But I waited for a long time. Then came 22nd of April this year, right? The following few slides is the sequence of events that happened on that day. So I work at SameGrep, who is a code scanning tool, which is a code scanning tool. We got a blog post from Aikido saying that, hey, we observed recently 2 malicious packages. One is named Cube Health Tools, and one is named Cube Node Health. So one affects NPM, one affects PyPy. Apparently, they are both affected with malware, right? So since we are also a code scanning tool, we also check that is any of our clients using that, because it is our responsibility to like inform them that yes, this is affected, this is malware, don't worry, we have detected it, so, right? So what I did was, there is also another vendor called Socket, probably you've heard of it. I went to Socket to check because, I mean, we wanted to verify that this information is correct. It should be across many vendors if this information is correct. So if you look at the top screenshot, it says 11 hours ago because it was taken on 22nd of April. So the version was released 11 hours ago from that day, and Socket did not say anything. But I found that on PyPy, there is also the same named package, and that it shows that it has a malware. So I was a bit confused, like Aikido says NPM, this one says it's clean, what's going on? So like, should I do it? Should we not do it? What to do? So then what I thought, let's see what's inside it. So in the Cube Health Tools, this is on the top left is the package.json. There is no pre-install, post-install, nothing. It says there are 3 files. This is the index.js, and index.js has these 3 lines. It says like, go into pre-build, require pre-built add-on.node. That's it, nothing more. And then there is add-on.node, which is a ELF file, executable. So I thought, okay, if it's a virus, I should upload it to VirusTotal, right? Malware should tell me anything. I did, and it did not tell me anything. So it was green. I thought, okay, maybe what's going on? I want to see more. Then I did what any security researcher would do as nowadays, go to ChatGPT and ask ChatGPT, hey, I have these 3 things. How is this called exactly, and how does it work exactly? And ChatGPT said like, okay, require add-on.node files are a special file. It resolves the runtime path, and it has these 2 things, which is NAPI register module and NAPI module. If these are called by default. So if the binary indeed had it, it would run that particular function. So then what I did, run Ghidra, opened the binary, and I saw, okay, I see, yeah, one of the functions is doing nothing. The other one is calling init. I said, okay, let me see what's in init. Now, I'm not good at reverse engineering, but I have played enough CTFs in my student time that I have become good at guessing, or how I call it, guesstimating. So from this, what I found that, okay, at the very last, there was an exec-l call. I said, okay, why are you doing exec-l? Okay, let's see. Then I saw like it's writing 2 things. And I said, okay, well, something is being written. What is being written exactly? So then I traced it, and then on the left you would see that there is a local var which is k XOR e. I said, okay, if it's there, it should be in the memory. On the right hand side, I found that, okay, these are the byte values. So I can XOR this with this. Let me see what I get. And I XORed it, and then that out comes that script, which is basically it's downloading a stage 2 loader and then running it. So at this point, I had enough evidence that, okay, this is bad. I should mark it as bad. So at that point of time, on 22nd April, we did not know what stage 2 did at that point of time. Now we know, because obviously many people have looked at it. And so it does process masquerading, and it also reverse tunnels. It is not just a backdoor, it taps on your AI toolchain. It kind of like monitors what is going on beyond, like in your normal calls with interactions with the LLM. And so it is kind of like traffic hijacking, and it uses Chinese LLM routers. So that was one of the discoveries of stage 2. right? So this was a good, fun exercise for that day, that find out what it is doing actually. Right, so now what I want to introduce is something called the window of opportunity for the attacker, and conversely, the window of exposure for the defender, right? So assume that I am an attacker and I release a malicious package at 4 o'clock today. Now, from that point of time, there are many, many security vendors whose job is to check, like, okay, anything that comes out, I'm going to analyze it, right? Or there are many individuals, independent security researchers who do the same. So at some point of time, they will determine that is this package, yes, good, or no, bad, right? And from there on, they are going to report it to NPM. NPM will take it down. As soon as NPM takes it down, does not matter if I want to install that package, I cannot get it. So I will not be affected. So my opportunity is from the release to NPM takes it down. That is my window. And I want this window to be as small as possible. For the NX attack, this window was 4 hours. For the Shai-Hulud worm, this window was 4 days. The reason being it's a worm, it kept propagating. Right, so could we use AI to kind of like detect these malwares? So I'm talking about a pure AI system where package comes in, goes through the AI, gets a marking, yes malware, no malware. So for the NX attack, if I upload that to ChatGPT or Claude, it can easily identify it because it is readable code. It can quickly say, hey, this is malware, this is what it's doing, this is the intent, exactly everything. Do we need deny by default here? Probably no, because we know what it's doing. Let's look at Shai-Hulud. I do not know if you can read the last line, and you will see a recurring pattern. The pattern is, if you see that after the read, it says the file is too large. Let me read it in chunks. That is a pattern that we'll see recurring. What Claude said for this is, this appears to be a production-ready minified bundle intended for application that needs to interact with AWS services. This is not a malware. That's what Claude said. And this is not like a one-time experiment. We repeated it a couple of times. So every time it said this has something to do with AWS, the sentence is not exactly the same, but the outcome is the same. Okay, for obfuscated code, chalk debug one, which was the cryptocurrency stealer, you'll see the same pattern. This file is very large. Let me search for patterns. For this one, it correctly identified every time that this is a malware. I don't know how. For Shai-Hulud 2, this file was 9.6 MB. Same thing, let me read it in chunks to understand. And it came with the conclusion. Remember, I told you to remember something.google.com, something.google.star. Apparently, Claude read that part and it thought, okay, it has something to do with Google, so it's a Google Cloud Secret Manager. I even followed up with the question, is this malware? And it said, don't know. So yeah, we can see the problems here. But the good thing is, if you very strongly prompt, like, hey, kind of like use a sliding window analysis type, this, that, then yes, it can reach there, that this is a malware. But you need to be like very, it needs, how do I say, very strong prompting, not a loose question like what is the intent. For the binary, not only Claude, but GPT 5.5 correctly identified this as malware, and it listed exactly the steps what it's doing, and exactly the steps that I also showed that I had to do manually, right? And the observation here was ChatGPT 5.5 did it like in 1 minute, whereas Claude Opus 4.7 and Sonnet 4.6 took 10 minutes. Reached the same conclusion, 5.5 was just like faster. Right, so what are the issues that we saw with potential full AI analysis? Full AI analysis. So every time the malwares are greater than the size of the context window, that is how they design it. So you cannot read it in one go. You have to chunk it. The AI chunks it, the model chunks it. Depending on which chunk you read, your outcomes are different. It cannot stitch the chunks together somehow. Sometimes it gives, yes, it's a malware. Sometimes it gives no. There are adversarial codes specifically designed to avoid static analysis. There is an example by Checkmarks. They used Claude security to review a file or an app. And in the function, there was a function which was doing a netcat operation, but on the top, they had commented like, this is unimplemented. When it will be implemented, this will do this, 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 this. Claude security completely missed it. It said everything is good. So what are the possible solutions? Well, we can use like vendor-provided tools, but like that is good for organizations, I get, but like for individuals, what can you do for free, basically? So we used to say latest and greatest, and now it has been revealed that latest might not be the greatest. And also, it is a good time for that meme, hold up, wait a minute, something ain't right, that meme. So even like paid vendors are using something called a delayed install. So any new package that comes out, within the first 24 hours, it will not be installed. It will wait for a 24-hour window. That is, it is trying to minimize the window of opportunity or the window of exposure. Another thing that we can do is we can use ignore script, because we saw many of the attacks, like not all, but many of the attacks leverage the post-install and pre-install. So if you turn that off, yeah, you are safe from that. So what is our opinion is NPM is run by GitHub. GitHub is run by Microsoft. I am broke, but Microsoft has money. So if Microsoft ran a tool on their end, where it so happens that whenever you upload a package, you want to publish a package, I'm going to do some vetting. I'm going to run a tool. I'll look at it for 7 days, 1 day, 2 days. If I find something, I'll just not publish it. Why not do this? I have no idea. So is the saga over? We saw like till last year, May 11, 2026, Mini Shai-Hulud. May 14, 2026, this month, there is a new malware which is affecting the Node IPC package. Right? So this is going to continue, and the attacks might get more and more complicated. So just to, how much time do we have? Okay, so this Mini Shai-Hulud was an encrypted malware on top of obfuscated. There was 3 layers of encryption. It is getting more and more complicated. So yeah, I think that this is going to continue and we should do something about it. And better NPM does it than others. That's it. If you have any questions, let us know. Thank you for your time. I mean, I have said my opinion to my seniors. I mean, is it being recorded? No, so my question was like, is it a fixed game that I cannot win? Because it looks like it. Because like, obviously this is the ideal solution. Nobody can deny it. Like if NPM does something from their end, yeah, that's gone. Like, we don't need to take any headaches, or like, there is no need for tools. Like, even the tools that are available for the public, why not Microsoft buy that and run it on their end? That is also like same thing you're doing, like vetting at the source is what we think is the best option. Yes. So one of the reasons I hear is like, it's not implementing it is because of the ease of publication and like the ease of the community in like, if there is like an statement that if people have to go through all of these vetting process, then people will choose a different package manager. Like they will go to PyPy or a different ecosystem, and obviously NPM somehow doesn't want that. I think it's a reverse actually. Like right now, if you can guarantee that nothing malware comes to my ecosystem, you are winning. Oh, why it is named that? That I don't know.
It's a big worm.
So yeah, it's Dune themed mainly. So so in mini Shai-Hulud, what happens is like in Shai-Hulud 2, the repositories was randomly named. In mini Shai-Hulud, what happens is they have a list of keywords like Lisan al-Gaib, let's take it, right? So they will create a repository with like any 3 combinations of words from that, like with hyphens. That is how they do it. And the description says mini Shai-Hulud appeared. So it's kind of continuing on the Dune theme somehow. And recently, Team PCP probably has published the Shai-Hulud malware source code. I don't know how legitimate that is, but seems good.
Shai-Hulud was the first self-replicating
Worm.
So I mean, if that's worth anything.
All good? Yep.
The first like supply chain self-replicating, like NPM self-replicating worm. Yeah.
Okay, good. Thank you for your time again.